Hello everyone, welcome to the session 3 of module 2. In this session, we'll start with the new chapter called as process scheduling. So in this chapter, we're going to discuss what are the basic concepts with respect to the process scheduling and scheduling criteria, and also the algorithm with respect to the process scheduling, multiprocessor scheduling, and the last concept is thread scheduling. So when you have a single processor system, you know that only one process can run at a time, but all other processor has to wait until your CPU is free and that can be rescheduled. So the next is what are the major objectives of your multiprogramming, which means that you have to maximize your CPU utilization. So in order to maximize your CPU utilization, this multiprogramming will comes into the picture, which means that, see, you may have a process. That process is not only meant for CPU execution, but also that process might be waiting for some other IO request. So whenever a process makes an IO request or IO execution completes, your CPU has to sit idle. Means the CPU is in the waiting state. Because the CPU is waiting for the process to complete its IO operations. Means the time which is meant or which is used for waiting for the process to complete its execution, that time is called as your waiting time. So your CPU is in, means your CPU is in the waiting state, and that entire time is wasted. So no any useful work is completed there. So with the help of the multiprogramming, we can use this waiting time productively. So how actually it happens? So by keeping your several processes in the memory at one time. So whenever one process has to wait for IO operations, or it has to it is doing some IO operations, so your operating system can take the CPU away from that process and can give the CPU to the another process. So this pattern will continue. When every time one process has to wait, another process can take over and can make use of that CPU. So this is actually the objective behind your multi-programming with respect to the CPU utilization. So remember this one, scheduling is a fundamental operating system function. Almost all your computer resources are scheduled before the use. So here you can see the next concept, that is CPU IO burst cycle. For a successful CPU scheduling, that depends upon the properties of your process. Whenever your process starts its execution, which come across with the two different cycles. One is with respect to the CPU execution and another is IO wait. So the process will alternate between these states. Whenever your process starts its execution, it begins with the CPU burst, and also that is followed by your IO burst, and again with the CPU burst and followed by the IO burst, and finally it ends with the CPU burst by ending with a system request to terminate its execution. So this is with respect to the IO burst and CPU burst cycle. So whatever the time which is spent on your CPU, it is called as CPU burst, and your process is waiting for some operations with respect to the IO, and that time is called as your IO burst. And also you can see here in this figure, this is your burst duration, which is in the form of milliseconds and also the frequencies. So the curve is, you can see it is characterized as exponential or hyper exponential with the large number of short CPUs and small number of long CPU bursts. So whenever we come across with the IO bound programs, we may have smaller CPU burst. This is with respect to the IO bound programs. But when you have an CPU bound programs, you will have longer CPU burst. So you can see this in diagram. When I consider IO burst programs, you will have so you can see this in this diagram. This diagram is an histogram of your CPU burst duration. You can see this in diagram. So maximum number of CPUs are having the burst time which is below 8, and smaller means maximum number, but smaller number having the longer CPU burst. See, now next the topic is with respect to the CPU scheduler. Before that, we shall start with the diagram of your process state. Here, whenever the process is created, which is in the new state, which means that that process has been created, and that process, if it is needed some of the execution or some of the tasks to be completed, that is sent to the ready queue. So that is, the process is waiting or which is ready for its execution. Whenever the CPU is free, the process is taken from the ready queue and given the CPU, and that process is called as which is in the running state. Once it completes some of the CPU tasks or some of the CPU burst, now it may need some of the IO events to occur, or it may wait for some of the IO operations to complete. So that process is sent to the waiting state. Means the process is in the waiting state. Once it completes its IO operation, again that process is sent to the ready queue. From the ready queue, whenever the CPU becomes free, that process is taken for its execution. Once it completes, means ready to running, running to waiting, and waiting to ready. So this keeps on looping until your task is completed. Once it is done, the process is terminated. So this is the how actually it works with respect to the process execution. So what is the purpose of your CPU scheduler? Whenever your CPU becomes idle, your operating system has to select one of the process which is in the ready queue that to be executed. That selection process is carried out by the CPU scheduler, or it can also be called as short-term scheduler. What actually this scheduler does? This scheduler selects a process from the processes in the memory that are ready to execute and allocate the CPU to the process. See, whenever we use some of the scheduling algorithms, that ready queue might be implemented as your first in first out queue or priority queue, or it might be a tree or simply a unordered linked list. So all the processes in the ready queue are lined up, which are waiting for its chance to run on the CPU, and the records in the queue are generally your process control blocks of your processes. So this is with respect to the CPU scheduler. The next one is we shall see with respect to the CPU scheduling, where actually the decision takes place. There are four situations out there. The first one is whenever the process switches from the running state to the waiting state. So this is might be because of some of the IO request or invocation of wait for the termination of any one of the child process. This is your first situation where your CPU scheduling decision can be taken. The second one is whenever or when a process switches from running state to the ready state. This might be because of any interrupts might have occurred. This is your second situation. And the third one is when a process switches from waiting state to the ready state. That might be because of your IO operations might have completed. And the last one is your process terminate. That is, after the completion of your process execution, it might be terminated. So these are the four situations which comes under your CPU scheduling. So here you can see the situation number 1 and 4. This is first one, and the fourth one, this is. There is no choice with respect to the scheduling, but whereas for situation number 2 and 3, there is a choice for your scheduling purpose. Means at least one of the process should exist in your ready queue. So that process is selected for the execution where you can make the scheduling operations, or you can go with the scheduling of the process. Whenever the scheduling takes place under circumstances of 1 and 4, then that scheduling scheme is called as non-preemptive. That is, it can also be called as cooperative. So otherwise, the scheduling which is done under second and third decision, so that scheduling scheme is called as your preemptive scheduling. See, now let's see what actually the non-preemptive scheduling and preemptive scheduling. Assume that you have process and also you have CPU. So the process wants to execute some of the task. So in order to complete that, the process needs CPU. So under your CPU, under your non-preemptive scheduling, once the CPU has been allocated to the process will keep the CPU until it completes its task. So once it completes its task, it might be terminated. So the process keeps the CPU until it releases either by the terminating or by switching to the waiting state. So this is with respect to the non-preemptive scheduling. So when it comes for the preemptive scheduling, the same thing. Assume that you have a process 1 and a CPU. So assume that right now your process wants, P1 wants some task to be completed and CPU has been allocated. So there may be some situations when another process occurs or where another process comes into the picture and which is having higher priority than this P1. So the CPU will be terminated for the P1 and the CPU will be given to the P2. So the preemptive scheduling, in the sense, this is the scheduling which is derived by the idea of prioritized computations. So the process that are runnable might be temporarily suspended when the higher priority or higher prioritized process comes into the picture for its execution. So this is with respect to the preemptive scheduling. What is the disadvantage of this preemptive scheduling? The first one is incurs a cost associated with the access to the shared data. and also it may affect the design of the OS operating system's kernel. So this is with respect to the preemptive scheduling and non-preemptive scheduling. So the next concept is with respect to the dispatcher. So this is an important component which is involved in your CPU scheduling functions. So what actually this dispatcher does? This dispatcher is a module which gives control of the CPU to the process which is selected by the short-term scheduler, or it can also be called as CPU scheduler. So there are some functions which involved in this dispatcher. One is context switching, second one is switching to the user mode, and the third one is jumping to the proper location in the user program to restart the program. And remember, this dispatcher should be as fast as possible since it is invoked during the every process switch. And you have another important term is called as a dispatch latency. What actually it is? It is the time taken by the dispatcher to stop one process and start another process running. So this is called as dispatch latency. So these are all the basic concept with respect to the CPU scheduling. What and all we have discussed? We have discussed what actually CPU IO burst cycle, CPU scheduler, preemptive scheduling, that is preemptive scheduling and non-preemptive scheduling, and the last concept is your dispatcher. Now let's see the scheduling criteria. There are so many algorithms which can be used for your scheduling purpose. In order to make a choose which algorithm to use in a particular situation, that mainly depends upon the properties of the various algorithms. So there are many criteria that have been suggested for comparing your CPU scheduling algorithms. These are the basic scheduling criteria. One is the CPU utilization, throughput, turnaround time, waiting time, and response time. We shall see one by one. What actually the CPU utilization? See, we want to keep your CPU as busy as possible. This CPU utilization can range from 0 to 100%. It is with respect to the concepts perspective, but when it comes for in reality, it should range from 40% to 90%. 40% is for your lightly loaded system and 90% for your heavily used system. So this is with respect to the CPU utilization. Second one is the throughput. So if the CPU is busy in executing some of the process, which means that some work is being done. So one of the measure of work is the number of process that are completed per unit time is called as your throughput. What actually the throughput is? The number of process that are completed per time is called as throughput. So for example, for a long process, that might take one process per 1 hour. For smaller process or shorter transactions, they might take 10 process per second. So this is with respect to the throughput. What actually the turnaround time is? Turnaround time, it is an important criteria which tells that how long it takes to execute a particular process. So here it is an interval. Remember this one, it is an interval from the time of submission of the process to the completion. Means it is the starting time, or we can say that on which time the process has been submitted for its execution, from here till it completes its execution. That is, once it executes, it is terminates. So in between, it might have gone under so many cycles, like it might be waiting for, or it might spend for waiting some of the IO operations to be done, or it might waiting for to get into the memory, or executing on the CPU and doing some IO operations. So all this will be considered as your turnaround time. So this is with respect to the third one. So the next one is the waiting time. What actually the waiting time is? Remember, you have a CPU scheduling algorithms. That algorithms does not affect the amount of time, not with respect to the process execution or doing some IO operations. It affects only the time or the amount of time that a process spent waiting in the ready queue. Remember this one. What actually the waiting time is? It is a sum of periods which is spent waiting in the ready queue. This is fourth one. What actually the fifth one is? Response time. So the response time, we can call it as, it is the time from the submission of the request until the first response is produced to that process. So this measure is called as response. See, it is a time which is taken to start your responding, not with respect to the time it takes to give an output to that particular response. So this is your response time. So these are the 5 scheduling criteria. So till now we have seen some of the basic concepts and scheduling criteria. In the next session we shall see with the scheduling algorithms. Thank you so much.